So so now we are gonna understand what is the bias theorem, and we'll see first definition and one by one formula and why it is useful, where it is useful, and examples. And the definition is like bias theorem updates probability using the node evidence. Bias theorem is a method used to update the probability of an event when the new information becomes available. So when the new information is available, so bias theorem updates the probability of the using new evidence. So in simple words, we can say we first make prediction, then we get the new evidence, we update our predictions. So before our evidence only we are doing prediction, and after getting evidence we are updating the evidence. That's it. And the formula is coming like P of A by B is equal to P of B by A, and P of A by P of B. So it is something like where P of A is equal to period probability, where what we believe before seeing the evidence, and B of A is called is like likelihood, means chances of evidence is A is true, and P of B is equal to evidence, and P of A by B is equal to what is the posterior probability, means updated probability. So I hope you understand this one. By example you can understand more. So here we are taking example like disease prediction, means 1% of people having the disease. A medical test is like 95%, means before taking a test the probability of having this is only 1%. After taking test the result is positive, means he has 95% of test accuracy. So now we suppose the test result is positive. So the question, where the question is coming, means what is the probability that the person actually has the disease after getting a positive result. So we are calculating what is the probability that a person is actually has the disease after getting the possible result. So bias theorem which helps to calculate the updated probability using the new evidence. I hope you all understand. Bias helps calculate actual probability of disease after a positive test. So before test we don't know what is the probability of having disease in the person, means we will think like he's having only 1%, we can't see, right? So after taking the result, after taking test, we know, we can guarantee like he's having he's having disease like 95%. So means if you can take corona, COVID, you don't know when the symptoms are coming, you just think it is a normal viral fever. After testing only it will get positive, means it will 95% accuracy. So it will update the predictions. It will update predictions. So here also the probability of disease after a positive results to calculate. So now we'll see why it is useful and where we are using in machine learning. So bias theorem help us updating predictions, and also machine learning use, and also Navi bias algorithm. So bias theorem which help us to update evidence by taking new evidence, by taking a new results. So it is used to improve decisions, and also make decision making, and also it improves accuracy when the new data arrives. So this is the useful of bias theorem. And the machine learning applications is something like snap detection, email detection, and sentimental analysis, and also test classification, and also medical diagnosis system and recommendation system. So we'll use for a snap email detection, whether we don't know, we'll having predictions like it is snap or not. After getting result only we can confirm that it is snap. So sentimental analysis, test classification, and also medical diagnosis, and also recommendation systems. Now we are gonna do in Python code. One second. Now we are gonna do in Python code. So here we are taking P of A 0.01 is because of period probability, means only 1% of people having disease. So that's why we are taking the period probability as 0.1, and something like A is equal to 0.95, and then B of B is equal to 0.05, and next bias is equal to then is something coming like this. So here we took p of a, which is a 0.1, and 1% of people having disease, and in line 2 we took a p underscore b underscore given of a, which is 0.95. means if a person is actually having the disease, the test shows the positive results like 95% of the time. Means next we are taking the p of b, which is 0.05, evidence probability of getting a positive test result, and line 4 we are taking bias, which is a p of b given a is like this, and we are applying formula here. So bias theorem formula to calculate the updated probability, and also we are printing bias. So let's see the result of this. Sorry, we done a mistake. Actually I need to give capital B here. Okay, I think now fine. So yeah, this one we are getting output, and yeah, so now we'll discuss something like we got 19% in output. So it means even after getting a positive test result, the probability of actually having the disease is about 19%, not 95%. That's why bias theorem is important. Consider both the test and result, how common the disease is in the population. So this is all about bias theorem, where we discussed about definition of bias theorem, formula of bias theorem, and also where it is useful in machine learning, and examples of bias theorem, and why it is useful, and it is used in some machine learning algorithm, and also Python code for the. So now we are talking something like sampling, and I hope you understand about probability, conditional probability, and also bias theorem. And if you daily practice with ML and machine learning with code, Python code means you definitely understand that. So now we'll see what is sampling and where we are using, why it is useful, and the Python code on it. So let's dive into the topic. So definition: sampling means selecting a small subset from a large population. Instead of surveying 10 lakhs people, surveying 100 people, 1000 people. So we are taking subset from the large population. Instead of surveying 10 lakhs people at the same time, instead we are surveying only 1000 people, means taking a small subset, and also we are sampling, we are what investigating, or we are selecting small subset, and also we are surveying. So it is like, instead of analyzing the entire population, we analyze a small representative groups. So for example, we'll see that suppose India has 140 crore people. India has 140 crore people, right? So if we want to know who will win an elections, we don't ask all 140 crore people, right? So instead of, we ask a sample of maybe 10,000 people and use their response to estimate the result. So this process is called sampling. So once again, I'm explaining what is sampling. Sampling is nothing but selecting a small subset of data from the large populations. Instead of analyzing the entire population, we analyze small representative groups. For example, suppose India has 140 crore people, means if we want to know who will win in the elections, we don't ask 140 people. We ask only certain subset of 140 people. Maybe we'll ask like 10,000 people, and we'll use that response to estimate the result. So this process is called as sampling. So in sampling, why do we use sampling? Means it saves time. Imagine you have a data set with the 10 million records. You have a data set with the 10 million records, and training a machine learning model on all records can take a lot of time. If you want to train all the records, means it will take a lot of time now. So, and also requires more memory, and cost is more. So we select a small samples that represent the whole data set. So taking all 10 million records is very impossible, because that has very large data, large information. So it takes a lot of time, it requires more memory, it requires more money, and it will cost is very high. So we select the small samples that represent the whole data. So it will, the benefits of this means it will save time, save money, and also faster model training, easier data analysis. I hope you understand. And now you are seeing types of sampling. In types of sampling, we have something like 6 samples, means random sampling. First we'll go for random sampling. In another video, I'll do brief content on this. So if you have any doubts, please comment down. And in random sampling, every record has an equal chance of being selected. Okay. For example, if we take data set has 10 data values, and in the 10 data values any record can be selected, means any record it has, means if, okay, for example we are taking 10 records, so in 10 records any 3 records can be selected, means 3 records now, 3 records now, after 3 records after, likewise we are giving chance to every record to get trained, so any record can be selected. So in stratifies sampling, divide data into group and take samples from each group. So like what we are seeing, we have this data set and we are dividing the data sets into group, and we are taking samples from each group. So for example, students we having 50 boys and 50 girls, we'll take 10 boys 10 girls equally, and this ensures every group is representative. For example, in college we have groups, right? In college events we have groups, right? Like green group, yellow group, like that. We select some certain groups, like if yellow group has 30 student boys, means 30 student girls, means we'll select 10 boys 10 girls for doing leadership, for a discipline leader, like that we'll take some certain number of students equally. So next is systematic sampling. Systematic sampling means selecting every nth record. You're selecting every nth record. So in example, like we having 10 records, so we are choosing third records. Every third records means selecting systematically way in nth record. They're selecting systematically way nth record, means in 10, okay, we have 10 samples. We're selecting nth records, means third into 3 records, means 3, 6, 9. So we are choosing like that. And we have another type of types also. Every record has equal chances. Okay, sample from each group. We have another two more records, 2 more samples, like 2 more types. We'll discuss in another video. So now we'll see where it is useful and why it is useful in machine learning. So in machine learning, it is used in train test split. Suppose 1000 records are there, means 80% of records is going for training, 20% of records is going for testing. The test data is like a sample of original data. So already we done in machine learning, right? In previous video, in day 1 video. So we took 80% of data is going for training and 20% of data is going for testing. So this is called as sampling. So the test data is sample of the original data. And second, we are taking as data collecting customer reviews, surveys, responses, and also sensor readings, and also other uses sampling. So next one is surveying analysis. Companies don't ask every customer, right? If a customer is buying products, if bulk customers are buying products, means they cannot go for each customer and ask like what is your experience with this, they can't ask feedback, right? They'll select only few peoples and they'll take samples from the small data, a small group, and analyze the feedback, right? So this is about sampling. We till now we've seen what is the sampling, what is the sampling, why do we do sampling, and types of sampling. There is 3 types only we discussed, and then what is the machine learning use, and then now we'll see Python explanation also. I'm deleting this record. Now we'll do Python. So it is come like importing pandas, data. I'm selecting randomly, so data is equal to, I'm taking randomly. You can give whatever you want. So this is the data I'm taking. Now I will take sample. Sample is equal to pd.series will take pd.series of sample of 3. We'll take sample of 3 and print sample. So this is in line 1 we are importing Python library, and Python library help us to work with the data, and here we are creating data set which containing 10 values, and also we are taking Python code. Sample is equal to pd.series data.sample3. What happens here means we are converting the list into the panda series, and also randomly selects 3 values. So it will select randomly 3 values, and for example it will select 836 means, or to 10 5 means every time you run it, you may get different values because the sample is random. So lastly we are displaying the random selected samples. Let's run this one. So we got a result like this. It's selected randomly. Sample selected. So we'll try to take real-time example. Like imagine the teacher has 100 students. So instead of checking all 100 student notebooks, she randomly selects 10 notebooks. Those 10 notebooks from the sample. She uses them to estimate how the entire class is performing. So when someone is coming for checking, they will select random books, right? Like 3-4 books, and they will estimate how the class is performing. So I hope this is not more interesting, but we have to try now. So this is all about sampling. Now we are going to see something like a normal distribution. And till now we discussed about many things, like we discussed about probability, and also conditional probability, and also bias theorem, and also sampling, and now we are going to see normal distribution. So I hope you will also try with me. And I know I done mistakes, but I want to improve. I want to improve my knowledge. Likewise, I want to explain you guys. I want to explain you. So now we are talking something like normal distribution, and the video length is so long. That's why I need to do lot of parts, like 1 to 3 parts. So let's do another video for normal distribution also. Okay guys, let's see in another video.